Hello Year 10. In this lesson we're going to be going through the content on Transformations 1, which is referring to pages 140, 141 on Kubito. Okay. So we go through, first we're going to go through some reflections. So a reflection is described using a mirror line, or sometimes referred to as a reflection line. Now this line will have an equation. So in this case here, for example, we've got A has been transformed to give you B, and it has been flipped over this line here. So this we say it's reflected over this line, and this is the line x equals 3. So let's go through some few examples of reflections. So here we've got a shape, and we're being asked to reflect the triangle in the line y equals negative 1. Okay, so y equals negative 1 is describing all the points where the coordinate will have y as a negative 1, so which is all of this bit here. So I've drawn the line y equals negative 1, I've labelled it, and then now we're going to just reflect it. Okay, so looking at that shape, okay, I'm just going to take a corner, okay, count the number of squares from the mirror line, so that's 1, 2, 3, and then repeat it on the side, 1, 2, 3. Okay, and if you repeat all that, we will get the shape here. Okay, and we're going to label the new triangle B. So this is triangle B. Okay. So question 2. Reflect the triangle in the line x equals 0. Okay. So the line x equals 0 has all the points where the coordinate x will have the value 0. So that's going to be, for example, 0, 1, 0, 2, 0, 3, 0, 4. So anywhere in the in this line here. So this is the line x equals 0, or we can sometimes call it the y-axis. Okay. So be aware that the x-axis is called likewise y equals 0. Okay, so we've been asked to reflect it in the line x equals 0. So I won't draw it, so it's already there. So we're going to reflect the triangle over this. Okay, so if you take a corner, it's 1 away, so it should go here. Label this triangle C. Okay. Another example. We'll reflect the rectangle in the line y equals x. So y equals x is all has coordinates where y and x are equal. So that's 1, 1, 2, 2, 3, 3, 4, 4, and so on. So this line here is the line y equals x. Okay, so label it, and that's our mirror line. So with this, just have to be careful because it's a diagonal line, so you can either do this, okay, or we can use a tracing paper as well. So if I do it this way first of all, so that's the point A, reflecting it over the mirror will take us half a diagonal square away here. Take corner B, reflecting it over the mirror line will take us 1 diagonal and a half, so it's going to go here corner D is one diagonal away from the mirror, so it's going to go there. And once you've done enough, we could see the rectangle is going to be here. So using a tracing paper, I will line up the tracing paper on the line, trace over the shape, and then if I flip this over the mirror line, should be equidistant, both the object and the image should be equidistant from the mirror line. Okay, so another example. So here's shape A. This time we're going to reflect the triangle in the line y equals negative x. Okay. So y equals negative x will be a line going as follows. So when x equals 1, y will be negative 1, x equals 2, y will be negative 2, and so on. So it will be a diagonal line going across like that. So that's y equals negative x. Okay. So let's reflect over. So take a corner. I'm going to take the nearest corner to a mirror line. That's one diagonal away. So it's going to go one diagonal away on the other side. Okay, so take this corner here. That's two diagonal squares away. So I'm going to go two diagonal squares away down there. Take this corner here. That's 1, 2, 3 diagonals away. I'm going to go 1, 2, 3 diagonals away. Okay, so once you've got the corners, we should be able to draw the shape. So next we're talking about, they're talking about rotations. So to describe a rotation, we need to give the center of rotation. This is the point around which we will turn an object. We need the angle of turn, and we need to know the direction, which is described as clockwise or anti-clockwise. Okay, so let's go through some examples. Again, it will be quite easy if you have a tracing paper this. If not, we'll try and explain how we can get through it as well. So here's a shape ABC. We're going to rotate it 180 degrees about the center 1, 0. So 1, 0 is this point here. Okay. So I'm going to trace the shape. Okay, so rotate it 180 degrees, any direction. Okay. So So that's 90. And that's 180 degrees. Okay. So once we know where it is, I can mark up the points. Okay, so we should find, so when I rotate it, that this shape, this corner A, will end up the same distance away from the center of rotation, because it's 180 degrees. Likewise, this point here will end up same distance away from the center on the other side, and it will be a straight line because of the 180 degree turn being a straight line. Okay, another example. Okay, so this time we're going to rotate the shape 90 degrees anti-clockwise using the center 5, -1. So first we'll mark the center 5, -1. Okay. So trace over it. Okay, so we're going to rotate it anti-clockwise 90 degrees. Okay, and then I know where they go, and you can mark this in turn. And there's the rotation. Now, if I take, look at her again. So if I take a corner, so let's say that corner there here of the shape, once rotated, that ends up here. So it should, so that movement there will be 90 degrees. So that's moved 90 degrees anti-clockwise there. So that should, if you were to join those points with the center around which we're rotating, that should make the 90 degrees. Okay, so coming back, finally, we can describe a translation by specifying the distance moved right or left and then up or down. Translations are described by vectors. Now, a vector is just essentially, a translation is another word for a movement, so a vector describes the movement. So in this case, we use two numbers, two components, as we're dealing with 2D shapes, which is the top one will tell us movement to the right, and the bottom component will tell us movement up. So if I had something like 3, 2, so that will tell us we're going to go 3 right and then 2 up. If I had something like so negatives, so -1, -4, this will tell us we're going to go, because it's negative, that's going to tell us the movement to the right, opposite of the movement to the right, which is left. So it's going to be 1 left and 4 down. Okay, so let's go for some examples. So here's shape A. We're going to translate this shape by the vector -5, -2. So that means left 5, down 2. Okay, so easiest thing to do with these is pick a corner. So I'm going to pick this one and then move that corner left 5. So 1, 2, 3, 4, 5, followed by down 2, 1, 2. Mark it, and that should be enough to do the rest. So the translation is a sliding movement, so that shape is now slid left and then down. So it's going to be 2 to the right, 2 down, so 3 on this side, and then join the last corner together. Okay. So another example. Shape A. Translate shape A by the vector 4, 2 and label B. So first of all, this means 4 right and then 2 up. So again, pick a corner. I'm going to pick this one. Go 4 right, 1, 2, 3, 4, and 2 up. 1, 2. Which goes there. Okay. So that corner moves there. So I can then draw the rest of the shape in. So 1, 2, 3. And then 1 this way, 1 that way, 2 down. And we're going to label this B. Okay, write down the translation vector that would return B to A. So it's asking us to check the sliding moment this way. Well, that's going to undo what we've just done. So this is just going to be left 4, down 2. Finally, this is an example in the book. So let's go through this. So describe the transformation that maps shape A onto shape B. So A to B. So hopefully you can see from A to B that's a flipping. We've just flipped the shape, so we've just reflected the shape. Okay, so we just need to find the mirror line for this. Okay, I'm just going to trace that shape. So it's been flipped, okay, in one mirror line, okay. So So we just need to find that. Hopefully this is quite obvious if you take a corner and look at that one. So we just need the midpoints of the corresponding sides, or corresponding corners. So the midpoint of those is here. Likewise, if I take those two, look at that, join them together, the midpoints of those will be here, and that's enough for me to know the mirror line is going to be here. Okay, and now that's the line when x is 4. Okay, so we can describe this as follows. So A onto B is a reflection in the line x equals 4. Okay. So next we want A onto C. So A onto C, hopefully we can see that there's some sort of a turn. We just need to locate the center of that turn. Okay. So if I look at the corresponding corners, so I can see that that corner is here. This corner here has a moot, so I know the center is going to be here. So I know the movements, the rotations happen around here. So if I check that, we can see that's a rotation of a half a turn. So we can describe that then by saying it's a rotation about the point 1, 1, so that's the point here, through 180 degrees. Finally, shape A onto D. So A onto D is a sliding movement, so that's a translation. So just being translated. So we say it's a translation. And just again take a corner. So if I take this one here, and let's just see what's happened. So it's 1, 2, 3, 4, 5, 6. So it's 6 left, and then 1 down to get to that corresponding corner. So we say translation by vector six, 1. Now 6 left, so it's going to be negative. 1 down, so it's going to be negative. So please use the remaining of the lesson to go through exercise 7.3s. Note for question 4b, they say rotate the kite K through 90 degrees, negative 90 degrees, so that they mean there 90 degrees anti-clockwise. Okay, good luck.